morning, everyone. It is really great pleasure to be here and to present some research results. And I prepare some really personal talk for you. I will talk about the last 20 years of my life and my experiences sharing academic positions and business positions. And the common denominator is artificial intelligence, big data, discovery of knowledge, decision-making processes, and everything which relates to that. Let me give you very quick background on my business experience. So in 1999, I spent 18 years in the United States. At 1999, I was still there, and it will be better. Yeah. And at that time, I created my first software company, NewTech. And later, this company was sold to data warehousing company Netezza. And later, a few years ago, Netezza was bought by IBM. So some of my people I hired many, many years ago work for IBM at the moment. In 2004, I moved to Australia after many years in the United States. And the following year, I created another software company, Solvit Software. And it was, again, very successful enterprise in 2012. A few days ago, we celebrated 5th anniversary of that. We sold the company to Schneider Electric. And then, after a few years of enjoying life, 3 years ago, we created the third company, Complexica. And I will tell you a brief story, what happened over the last 3 years, and who knows what would happen with this company. But in the course of the last almost 20 years, I had the privilege of working with probably the largest companies in the world, whether it is IBM and General Motors and Bank of America and BHP Billiton, Rio Tinto, Xstrata, and many, many others. First part of the presentation, let me go back almost 20 years and let me share with you my first experience running some business, NewTech solutions in the United States. The first interesting problem we faced at that time was the following. This was the problem posed by General Motors. And all of you know that General Motors, they produce cars, but they are also involved in reselling their own cars, which are coming back to them after leases and rentals. 1.2 million cars are coming back to General Motors every year. This number would translate into few thousand cars which are returned every working day. And they used to have a team of data scientists. At that time, there was no term of data scientist, but they have a team of 23 analytic people, and their only task was to make a decision which car should go where, to which auction site. Imagine this situation. You arrive in the office, you look at the printout of up to 7,000 cars that were returned the last evening at different locations, and for each car, you have to make a decision. This car would go here, this car would go there, and there is only one objective, to maximize the profit for the company. And the problem was presented to us as very, very difficult for a variety of reasons. First of all, each car is unique. Make, model, odometer reading, special feature, sunroof, cruise control, automatic windows, this and that. Then you have seasonality issues. If you send, let's say, convertible to Chicago in February, you'd be regretting it for the next 3 months, for example. But this is easy. You have to take into account very complex transportation network, because some cars you may wish to send for longer distances to take advantage of some circumstances, some other cars for shorter distances. Then transportation trucks, usually they are capable of taking up to 10 cars from the source to destination. So there is a huge difference whether you are transporting 10 cars or 11 cars between 2 points. Suddenly you have discontinuity between 10 and 11. You need second truck, second driver. The cost would almost double. Also, you have a variety of market conditions. The gas prices would change very rapidly, very often. This gas prices would influence the prices for cars. Usually, the gas price would go up. Prices for sport utility vehicles would go the other way, and so on. But also they made two very interesting remarks. They said the worst part of this problem is so-called volume effect. Let's say you did your old data analytics, data mining exercises, and you discover that the best price for white Honda Accord is Jacksonville in Florida. You send 300 white Honda Accords to Florida, and you can guess what you do to the price of this car, which means that you can't solve this problem sequentially. You can't look at the first car and make a decision, look at the second car, make a decision, and so on. You have to look at the whole distribution, and you have to evaluate the whole distribution. And the second observation was the following. You better remember what you did yesterday, 2 days ago, or 3 days ago, because auctions usually are run every second week. So cars you shipped yesterday, 2 days ago, 3 days ago, are still in transit, and most likely you'd be selling these cars together with cars you distribute today. And here, later I realized it is one of the best examples I saw in my life when I realized this separation between knowledge and ability for making smart decisions. We had 23 very knowledgeable people, data analysts, and their efforts were supported by these blue books and black books and reports from individual auction sites. Still, this team, for all reasons I just mentioned, they were unable to make the right decision. What is the optimal daily distribution of these cars? Knowledge is great, but ability of making decisions is very different animal. This is additional personal remark. Some companies coined the term knowledge is power. But on the other hand, I saw many examples which is really not the case. You have to know how to use this knowledge to make smart decisions. In many languages, there are some proverbs which say there is no fool like educated fool, meaning the higher degree you have, the better probability that you would do something stupid in your life. So I have my doubts about this power of knowledge. And let me just again visualize the problem. We have several collection points where the cars are returned. All paperwork is done and cleaning processes are completed and so on. And you have a variety of auction sites. And the only daily task of 23 people was to make this assignment. This particular car from this location would go here and there. Later, if I have time, I can show you the system itself. It provided much more than that. You can play with variety of what-if scenarios. What would happen if I close this auction site? What would happen if I open additional two? You can use the system also for some strategic optimization. How many auction sites should I have to start with? They operated on 57 auction sites. But who told them that it is optimal number? So you can do variety of things, And the system was very, very successful. After 4 months of testing, General Motors discovered that the system is outperforming their manual operation by $213 per car, average lift. And you can say $213 per car is a miserable number. You don't pay much attention when you buy 1 or 2 year old car on auction. But on the other hand, $213 per car in the scale of 1.2 million cars a year made a big difference for General Motors. So the system repaid itself in a few weeks. And then I realized the following. Everyone at that time, 20 years ago, was talking about knowledge and data mining and this transformation of data into knowledge and so on. But on the other hand, as I tried to explain, I realized this enormous gap between knowledge and knowledgeable people and ability of making decisions. And the reason, I guess, for this gap is the knowledge always look in the past. It is rear view mirror. You analyze historical data and you know what happened. On the other hand, decisions are about future, and it is necessary to bridge this gap. So to bridge this gap, then we identify we needed 3 important components. One component is predictive model. You build a predictive model on the base of your knowledge, so you can tell that if you take this particular car and you send it over there, this is the most likely price you can get, with all probability distributions and confidence intervals and so on. And also you need optimization component, which would tell you this is the best possible distribution. You can't do better. And these 2 modules, prediction and optimization, they should work hand in hand. And then there is a third very important component. You have to close the loop. You have to create adaptive system because prices and environment, they change. You live in dynamic environment, you have to account for that. If we didn't do it, the system would be worthless in 3 or 4 months. So every Monday morning, apart from processing all cars to be distributed, they read also additional file of all cars that were sold the last week, the last 7 days. And the system calibrated itself. It looked at the predicted values and actual values, and all predictive models were updated. This is why they were able to use the system for many, many years. And at that time, I coined the term adaptive business intelligence to distinguish ourselves, what we are doing in the company, from classic business intelligence. Business intelligence, as you know, was this transformation from data to knowledge. And adaptive business intelligence, I thought, would be something different. It would be making this additional step from knowledge to decisions by adding these 3 important components: prediction, optimization, and adaptation. And at that time, I remember when I moved from United States to Australia, I wrote 2 books. One, and probably these 2 books are the least known books I wrote. The other are probably a little bit better on genetic algorithms and some other stuff. But adaptive business intelligence is just sharing with the audience on this interesting direction, how you can combine prediction optimization and adaptive loop into building intelligent systems. And the other, my favorite, basically this winning credibility, how you can start and run your technology company. Because it was my first business adventure, we made many, many different mistakes. And I try to put everything together and share with everyone how to do it, what things you should avoid, what things are really recommended. Anyway, in 2004, for a variety of reasons, after 18 years in the United States, I moved to Australia. And in February 2005, with a couple of other people, we created another company, Solvit Software. And again, we are doing a variety of very interesting projects until one day when we came across the concept of wine supply chain. I am not sure how many of you enjoy wine, and those of you who do may know that Australia is very famous for quality wines, especially Barossa Valley, next to Adelaide and so on. And we are working with very large wineries over there. And then we look closer at wine supply chain. Let me give you 1 minute tutorial about making wine. So first of all, you grow grapes. Then at some stage, you schedule harvest. You need people and machinery to pick up grapes. Later, you deliver them to crushers when you extract juice. Then there is a longest few months process where juice is processed on tank farm. Very often in Australia and other places, you have tank farms which consist of a few thousand of tanks, and some tanks are absolutely enormous, some millions of liters of juice. And you are following very, very special process of fermentation and cooling and maturity and stabilization and blending, of course, when you are merging different juices from different grapes. After that, you send everything to production line or storage, and then final delivery to customer. But then I realized that each of these steps is loaded with scientific issues. Predicting maturity of grapes is very important. Optimization of harvesting, scheduling of people and equipment, including weather component, is important. Crushing activity is very intense. Again, very sophisticated scheduling optimization algorithms are required here. Probably the most difficult aspect is processing of wine, because you have so many activities over there, and transferring wine from one tank to another, first of all, is very expensive. Second, you can't avoid it because of blending and different characteristics of different tanks. And it is very, very important to minimize the number of transfers. And this is each transfer, as I said, is very expensive, not to mention the quality of wine would go down with each transfer. And then storing and sequencing of bottling exercises, delivery network. Many, many interesting issues are there. When we arrive at the largest winery in Australia, we are really amazed to see their IT solution. It's a huge whiteboard, plenty of stickers, and a team of people investigating optimal solution. Or you can imagine easily excitement about what if analysis. If this and that happen, what do we do using whiteboard solution? So what we did, we developed many systems for them for this intake operation. Intake is from growing grapes until you extract juice. Then you have tank farm operations, and then you have bottling line operations. And so we delivered a variety of systems for different units of this winery. And then we realized one fundamental thing, which again started very interesting research. Let's say that in this, for the sake of this example, we have like 3 steps for making wines. Usually, and this is terminology of winemakers, you have variety of intake operations, so you are growing grapes, predicting maturity, scheduling harvest, equipment, people, crushing activities until you extract juice. Then you have this main activity in tank farm, which usually is between 6 and 9 months when you are making wine. Once wine is ready, you have all, they call it just bottling operations, but it is a little bit more. It is storage and delivery and everything. So we developed different systems for different activities, and then we realized one fundamental thing. Coming from academia, when I talk about global optimization, as opposed to local optimization, the concept is very clear. You have a function or you have a surface, you have many local optima, and the best of them is called global optimum, global solution. So the concept is vertical. In industry, they use very much the same terminology, but with very different meaning. Local optimization for them is when you optimize one particular stage of the whole process, of the whole supply chain. And then when they say global optimization, they mean everything from one end to another. And this was a very interesting concept. At that time, I realized there is no company in the world which would do global optimization for significant enterprises. Very often you have specialized software to do this, to do that. And the same is really in academia. When you look at optimization papers, you are reading papers about traveling salesperson problem, about knapsack problem, graph coloring, and you have millions of or thousands of NP-complete problems, and you try your best. But there is very, very few research which would look at some different processes which are interconnected with each other and try to get the best possible solution. Let me explain this, continuing this example on wine. Let's imagine the following situation. Bottling manager is getting a request. We need 700,000 liters of Shiraz. We have customer, you have to get 700,000 liters of this particular Shiraz. Next week we are making delivery. So bottling manager is calling tank farm manager saying, hey, I need 700,000 of this and that Shiraz. Then tank farm manager is looking at his tanks and he discovers a tank with 800,000 liters of this Shiraz. And there is a big problem at this very moment. There are at least two extreme possibilities. One possibility is to send the 700,000 liters of this Shiraz to make bottling manager happy. And then you are left with leftover of 100,000 liters of this Shiraz, which would be terrible because the oxygen level in the tank would be very high. The wine would go sour in a few weeks later. You can't use this tank for any movement and so on. This is from tank farm perspective, it is one of the worst possible solution you can think of. So the ideal solution would be to send everything, 800,000 liters of this Shiraz, to produce a little bit more of bottles of wine, and let's bottling manager to worry what to do with this excess. But from bottling manager perspective, it is terrible. I am not sure you know, the moment you bottle the wine, this would require placing a label, and the different countries have very different labeling requirements. The moment you place the label on the bottle, you restrict your freedom. You can send this wine only to Belgium, for example, and then the situation is very risky. So the bottling manager would do everything in his power to stay away from this decision. This is the difference between local optimization, when you try to satisfy requirements of one compartment, against global optimization, when you try to do the best for the whole company. And later, the following year, we discovered that many big companies operate very much the same way. In 2009, 2010, 2011, They were boom years in Australia because of mining industry, iron and coal. The prices were skyrocketing, and big players suddenly realized that optimizing their operation might be worthwhile. And in mining industry, you have mine planning, very complex problem in itself. Then you have processing of this coal or iron, getting appropriate grades. Then you have stockpiling issues. Then you have rail logistics, which in Australia is very, very important because very often you can single track rail with some points where two trains can pass each other. Then there is a port stockpile, and you have port logistics. And we are really amazed to see the largest companies in the world. BHP Billiton at that time was the 10th largest company in the world, including Google and Facebook and everything. And we are amazed that they have different managers for different activities. And the synchronization of their operations in the whole supply chain is basically non-existent. We are told that to analyze for them, to analyze one what-if situation. This train is delayed by 10 hours. What are the consequences? This is like 5 days exercise when hundreds of spreadsheets are being sent from one unit to another and millions of telephone calls are made. They maintain their operation for all silos, but they don't have any global view. So we thought it is absolutely fantastic chance. There is no software in the world. There is no system they can use. Basically, they are stuck with spreadsheet, their knowledge and intuition. And at that time, we were developing systems. Now, this is for mine planning. If you look only at one aspect, mine planning, you have no variety of things and different sectors with different grades and so on. I am just showing a few screens from one particular system, mine planning. But even if you optimize this mine planning to perfection, overall, it may have negative impact on the whole supply chain operation because you have to store it somewhere, because you don't have sufficient rail capacity and so on. So again, the name of the game was to optimize everything, to optimize the whole supply chain. And this is again a couple of screenshots of the most famous system, which basically the system was bought by all major players in Australia at that time. When you look at the different tabs of the system, and you can see, apart from this overview screen, the most important is integrated plan, but then you have this shipbuilding and ship loading activities and rail activities. All aspects of their operations were represented in one system. So, for example, you can go to stockyard and you can see what is happening at this moment at the stockyard. You can go to train dashboard. You can see all train activities and what is included in which compartment and so on. You can also go to integrated plan. And for example, you wonder, this is a particular ship which is coming to the airport on 15th of April. And you wonder, what would be the content of the load for this particular ship? You just click on a particular rectangle and you can screen the screen all the way down to train activities and so on. Anyway, for the first time, we try to provide this full visibility of their operation, not to mention that you have variety of reporting stuff. What was new from optimization point of view was that you were able to select a subset of objectives we are after. I would like to optimize only train logistics or stockpile activities, or I would like to optimize everything from end to end. Not to mention that the amount of data we are dealing here with was absolutely enormous. And again, we found that we are using the same principles. Predict knowledge, I mean getting all data, collecting everything into significant information, building predictive model, optimization, and adaptive loop, because sooner or later, once you make a decision, you would like to be sure that the decision is the best. And then you can also question the system. I spent 20 years doing research and optimization, but I haven't seen some features which business very often requires. If you supply some optimizer to any business, the chances are that the end user would question the results, saying, what the hell, what did you do that? Why the system is recommending this and that solution? I would do it different way. And it's very difficult to defend yourself saying, hey, this is optimizer and you know the system should know better. It doesn't work this way. And we are working at that time on explanatory features in natural language, so you can click at a particular element of the overall decision and the system would try to justify itself because of tide, because of hours of operation, because of this constraint, because of equipment or whatever. The system would give you the reason why particular decisions was made. And this is one of the also overall observation. You have to do everything to satisfy the end of the end customer, the end user. If you don't do it, the chances are that they won't use the system. And if they don't use the system, it is a failure of the project. Whoever is guilty, whatever the reason. You may have 5 Nobel Prize winners working on your system, on your software. The moment they don't use your software, whatever the reason, they don't like red color, whatever it might be, this is a failure of the project. This reminds me one of my favorite stories when a scientist discovered fantastic food for dogs. And actually he has proven by statistical methods that if dog would eat this food, would never get sick, the fur would be always shiny, and the teeth would be always white, and you have 20 bullets, nothing but benefits. But there was one problem only, no dog would eat this food. And this is the same with software delivery. Whatever you do, optimization, prediction model, data analytics, reporting, and so on, if you fail in delivery, in the sense that end users won't use it, that's over. And I remember at that time one of the last papers, I was still active in academia at that time, I wrote a paper with a couple of other people talking about traveling thief problem. And suddenly, over the last years, I am really happy to see that this idea pick up, and there are probably around 200 or 300 publications, even in IEEE Transactions Journal or Evolutionary Computation or some others. Here, I try to generalize this idea from the mining or wine industry in the following sense. Those of you who are from computer science or operations research, you know very well there are thousands of papers on traveling salesperson problem. And this problem is exercised left and right, and you have modern heuristic and variety of other classic algorithms for that. The same is with knapsack problem. But if you combine these two problems together, you are traveling through one city and another, and you have some items distributed in these cities, and the more you take, the slower you go. Is very simple, intuitive merge of two classic NP-complete problems. Suddenly, there are no known algorithms. Many things are unclear. You can't solve these problems sequentially. You solve TSP first and you move to knapsack, or the other way around. You have to solve these two problems at the same time. And this was also my experience from industry. You have many interacting components. You can't solve them separately. You have to solve them together. And this was very, very interesting and rewarding from this perspective. And now my final adventure. I am sure that this is the final adventure for myself. When we sold the previous company, we signed some very strict non-compete agreements, which, by the way, expired 5 days ago, which is good. But for 5 years, I couldn't touch really optimization. I couldn't touch supply chain, in particular mining companies and so on. So when we started our Complexica, we basically had a few brainstorming sessions, what we should really do. We can't do this, we can't do that. And then we are talking to a variety of companies and we realized one fundamental thing. And before I display the further content of this slide, let me ask you, if you run a company, and it really doesn't matter whether you are selling hot dogs or TVs or washing machine or software or whatever, data analytics services, what is the most important activity for your company? Definitely it is, yes? Related, but you can spend millions on marketing, but what is the most important actually is sales. If you don't sell, you die. It is as simple as that, whatever you do. So sales departments are the most important departments across the board. Whatever you do, selling is the blood for your company. So we coined the following term, which is opening many, many doors for us. We can help you to sell more at better margin. Are you interested? And I never came across any company which would say, no, I am selling, okay, I'm not interested in selling more. So we try to develop software over the last 3 years, which would help end users to sell more at better margin. So the problem is classic. You have plenty of data. All these companies these days, they are sitting on billions of terabytes of data. On the other hand, you have managers. These managers, they need decisions. They need answers for many, many questions. And the questions are billions of them, a variety. How I can capture margin or revenue, what products should I offer, how many sales reps should I have, which territories they should operate, what is the frequency of calls, how much should I spend on promotion and so on. All questions connected with sales. And probably, as you heard it already, the most popular approach, which is happening these days, these companies, they hire data scientists, not statisticians, not data miners, but data scientists. But it is a very expensive proposition because it would take some people, tools, and time to provide some result. And of course, if you have more and more questions, you need more and more data scientists. Some companies like Qantas, this famous Australian airline, they hired 200 data scientists. They have a team of 200 data scientists. They are dealing with a variety of questions. They are making a variety of recommendations. What we thought would be very, very interesting is to create AI-based software. And for marketing purposes, we called this software Larry. Like, this is very, very popular trend these days to call personal assistant by some name, and it sells better. This is no mystery in that. But Larry is basically a collection of smart algorithms which would help you to get there. Would provide some data capture, some preliminary checking, cleaning, data analytics, prediction optimization, learning components, and so on. And we try to configure this set of algorithms to provide some value for our customers. Now, this is almost the last slide, and I will show you 2 pieces of software. But we look at all questions which were posed by managers from sales departments, and we group them into 3 categories. And I call them strategic, tactical, and operational. On strategic level, you try to optimize the structure. How many reps should I have? Which territories they should operate? What is the frequency of visit? How can I build my team in the most efficient way? So it is strategic level type of questions. Then you have tactical questions, saying, let's say you are sales reps, you wake up, it is Monday morning, and you wonder which customer should should I see and what should I tell them? Personalized offers for different customers, very important issues. And then when you transact, it is operational level, all these substitutions and recommendations and little changes, and I will show you this in a few seconds. It is like an Amazon. Customers like you also are interested in this and that. But in one system, you can actually perform a lot. Let me show you this very, very briefly. We are towards the end anyway. Probably it was here. Yeah, this is this what-if simulator for strategic level. Australia is divided into some small segments which are called bricks, couple of square kilometers and so on. Then you can go to sales reps, you can model every rep, you can model experience of this rep and gender and some other duties and so on. So you can prepare your what-if scenario. You can make rep inactive. So you can try to see what would happen if I try to do very much the same with smaller set of reps. You can answer the question, what would happen if all my sales reps are, let's say, females between 25 and 30? What interesting question this might be for some industry. Then you run, so you can do it for reps, you can organize them in teams, you can look at different sales division, different practices. Here we talk about pharma companies in this particular case. But anyway, you create your own scenario, you save your scenario and so on. I won't bore you with details of the system, but the point is that you run a particular simulation. Of course, simulation would take a little bit longer than that. And at the end of the simulation, the system would tell you, if you do this and that, this is the most likely result. And I will show you the result in a few seconds. And so let me go to comparison view. You click at particular brick, and the system would tell you the original scenario would give you this and that performance, and after your modification, these exchanges of reps, territories, frequencies, and so on, this will be very different result. So basically, the company can play with different structuring scenarios, and they are getting the answers to what would happen if. And actually, the project was so successful, they asked to extend this by additional tab, which is optimization. And again, they said instead of worrying about 10,000 different scenarios and selecting scenario in manual process out of many simulation runs, I would like to ask Larry once, what is the optimal scenario? And this is what we would be delivering 1 month from today. And the second system I am going to show you is the following. You go to one tab, Customer Opportunity Profile. You select a horizon, let's say 1 week, and you ask Larry. And Larry would tell you what to do. Your particular sales rep, this is a system for sales reps. The system would tell you which customers you should see this particular week. And then you can ask for additional insights for the customer. You have variety of information. You have this wallet share. You have next best conversation. I guess from scientific point of view, this is one of the most interesting developments. Next best conversation. If I see this customer, what should I talk about? Each customer is different. Making this mass promotional activities, the same stuff for all customers doesn't work. So micro-segmentation and all stuff related to that. This is very interesting. Discuss requirements for coming event. In this particular hotel, there is a wedding in 3 weeks. The system, by exploring the web, would discover that, and the recommendation to sales rep is talk to them about this particular activity. And then you have quotes and orders, and with all stuff, with product substitution and everything. I won't bore you with that, but The vision at this moment is to create one system which would support all sales activity from strategic level to operational level, which will be very friendly, very easy to use, with variety of analytics and statistics and everything. So we are probably halfway through. We did fantastic progress over the last few years, and this adventure is really very, very rewarding. So let me jump to the very end of the presentation. Just a couple of concluding slides. Yes. As I said, for 35 years or more, I was working at different universities and different continents and so on. And only the last 20 years or 19 years, I am more and more involved in business. And 4 years ago, I retired from university completely, and I moved 100% into business. So basically, I lived 2 lives, especially during the last 2 decades. And I think it is very rewarding exercise and very rewarding experience, especially in life. This opportunity to apply your research ideas, whether it is adaptive business intelligence, combining prediction optimization and adaptiveness together, or looking at global optimization in different way, or doing something for sales departments on all different levels, looking into particular algorithm that may help. And on the top of that, over the last years, I got some, I think, recognition from research community. People were pointing at me and saying, oh, this is the guy who is working with industry, which is not that common, as you know, when you work in academia. But also, your personal life is changing in a dramatic way. This is additional observation I would like to share with you. First of all, when you are in business environment, you meet different people. Suddenly, this is like discovering a new world. So you are meeting interesting people. Professor Paprzycki 2 hours ago said it's not that often that you meet world champions in your life, no? But it may happen. You can build your house on the beach. You can drive nice cars. And what is most important, every evening you can sit on your deck, you can have a glass of red wine, and you can enjoy sunset, which is also very, very rewarding. So thank you for your attention.